So we've got a massive problem, right? Our water is just filled with microplastics. But what if the very act of trying to clean it all up was actually making things worse? Today, we're going to look at a pretty amazing new technology called PMM OpenWater that aims to solve that exact paradox.
And that really gets to the heart of the problem, doesn't it? How on earth do you remove trillions of these tiny, nasty particles from our rivers and oceans without accidentally wiping out the plankton, the microscopic critters at the very bottom of the food chain that everything else needs to survive?
All right, so to really get why this new idea is such a game changer, we've got to first understand the problem and, the hidden trap that comes with it. On one hand, the goal seems so simple, right? Just get the plastic out of the water. But here's the devastating catch. A lot of the usual methods, things like superfine nets, are just indiscriminate. Think of it like a giant dragnet. It catches the plastic, sure, but it also scoops up and kills the very plankton that the entire ecosystem relies on. I mean, think about that for a second. We're in a situation where we could literally destroy an ecosystem in our attempt to save it. It's the classic case of the cure being just as bad, if not worse, than the disease. And that just won't work. We need something way, way smarter. And that's exactly where this new nature-inspired approach comes in. Instead of just trying to muscle their way through the problem, the designers took a step back and looked at how nature works. And it all boils down to this one powerful idea. Manage the sorbent, not the particles. Basically, instead of manically chasing down every little bit of plastic in the water, they decided to focus on managing the thing that catches the plastic and let physics and biology do the rest. So what does that actually mean? Well, it means you stop thinking like a brute force filter and you start thinking like a gentle giant. The whole system is designed to intelligently and kind of passively guide the living things, the plankton, into a safe little detour, completely away from the trap before it even tries to grab the plastic. Okay, so this philosophy sounds great, but how does it actually work in the real world? Let's take a look under the hood of this gentle giant. It all comes down to this really clever three-gate system. First up, Gate A. Think of it like a whale's baleen. It's a gentle sieve that separates out the bigger stuff without any harsh pressure. Then comes Gate B, and this is cool. It uses subtle light and sound cues to just kind of nudge the plankton into a safe bypass lane. It's not forcing them, it's just guiding them. And finally, Gate C, the smart split. This is just pure physics. The channel is designed so the stiff, rigid bits of plastic go one way, while the flexible, living plankton just naturally follow the water down another. So simple, but so effective. So the plastic gets separated. Then what? It ends up in what's called the selective cassette. The inside of this thing has a special material with a natural, almost magnetic attraction to plastics. It's like a chemical static cling. But the outside has this biological non-stick coating that literally repels living cells so nothing gets stuck. And get this, magnets are only used outside of the water, just we're handling the cassette. Makes it super easy to retrieve and clean without ever putting anything magnetic into the ecosystem. All right, that's the tech. The theory is beautiful. But the real question is, does it actually work? Let's check out the scorecard. First, and this is huge, the target is to capture at least 90% of microplastics larger than 10 micrometers. I mean, that is an incredible number. It shows this gentle approach is also incredibly effective. But here's the other side of that coin, and this is what makes it a real breakthrough. The target for any significant loss in plankton? Zero. A big fat zero. No loss in their health, no loss in their ability to move. You get the plastic out, and you leave the plankton alone. That's the holy grail, right there. And if we zoom out a bit, this table gives us the whole picture. You've got that 90% removal and 0% plankton loss we just talked about. But look at the other targets. Almost no iron leaching into the water, so it's chemically safe. And the energy usage? Less than 5 watt-hours per cubic meter of water. So it's not just effective and safe, it's also ridiculously efficient. Okay, so the numbers look amazing. What's the plan then? How do we get this tech out of the test tank and into our actual rivers and oceans? Well, there's a clear roadmap. They're following these standard stages called Technology Readiness Levels, or TRLs. It starts in the lab, validating all the core ideas. Then it moves up to building real-world prototypes, like a pontoon for a river. And the end game? Long-term deployment in rivers, and even integrating them into offshore platforms. And you can start to imagine what that future could really look like. You could have these modular skimmers on pontoons and rivers, grabbing pollution right at the source. Or maybe barges, just cruising the surface of reservoirs, cleaning them up. You could even integrate these cleanup systems into old offshore rigs, basically turning them into giant ecological restoration hubs. The whole idea is that it's flexible and can be scaled up. And all of this brings us back to one final big question. For so long, it felt like cleaning up microplastics meant declaring war on nature. But what if we've been thinking about it all wrong? By shifting from brute force to this gentle, nature-inspired guidance, maybe, just maybe, we found a new way forward. So could this be it? Could this be the key to finally helping our waters heal themselves?